There we go.
You have to start again.
I'm not going to start again. I'm gonna. No, apologies for everyone watching the recording. We have covered factors and converting factors, and now we're at the as dot numerical, and we will continue from there. Righto. So now we know how to convert. Let me just get my notes right. We know how to convert a character to a factor to a character, and then changing that to numerical, like for instance when we use dates. Now we're going to start doing a little bit fun stuff. We're going to do some plotting, right? Let's say we're going to do renaming factors. Right, renaming. Let me just clear my screen a little bit so you can all just see renaming factors. So what R is very strong in is plotting, and I've been boasting about this from day one, correct? So I want to now plot, just with tidyverse, which we have, I want to plot the, let's say, the frequency data-ish, descriptive data, that's a better way of zooming in it, of the sex variable in the surveys data set. Someone unmuted. Just want to double check I'm not missing anything. No. I just want to also get my little chat screen up here so I don't miss anything. Super duper. So how do we do that? We are going to use the plot argument. So in this tidyverse, in this simplistic plot we're going to make now, we are going to plot in the survey data the sex variable. So, what happened here? We made a plot. How cool and awesome is this? So this is the basis of what we're going to be doing tomorrow as well in data visualization. But do you recall I said, please tie a knot into your ear? So I'm going to scroll a little bit up here in my, there we go. What do we see over here? I want us to quickly have a look here. So here's the legend. We know that females with, oh, my dog is barking, apologies, 15,690, but males are 17,348. But they were also missing data of 1,748. It's not picking up the missing data when we make the plot. Let's correct that, and let's now rename factors too. So what we're going to do is, we are going to use the add NA function. So let's use we're going to use everything we learned now above to convert, or let's say rename the factors, right? That's what we're doing right now. So let's start. We are going to create a new survey, a new variable called survey, sex, sorry, and we're going to use the sex column. We're going to run that. We can see it's been created, 2 levels, male, female, etc. We are now going to say, I want to see what levels are there. Yeah, Peter, go ahead.
When I went through you now, when I went along with you, I did plot surveys sex. Mine shows that NA.
Sorry, just say that again.
Mine, you see now on the plot, you have only female and male. Mine is showing.
Do you want to share your screen with us, and then I can see what's going on? So yours is already picking up the NA, right? Did you maybe do this on your own at home before you came to class today?
No, I was doing it with you now as you are teaching along.
Okay. Okay. So for yours, picked up the missing values. That's what yours did. But which is not the worst thing. You see there, it looks kind of right. You know, if you look at the legend, etc. So it might be something that you did yesterday to activate that or something, and it's not the end of the world, but follow along and see how we change the, you see where it says male and female under the 2 bars, right? But under that smaller one, it doesn't say missing value or anything. We're going to change that now. So you will be able to change that. So don't worry about that, okay? Okay, thanks, Peter. I really appreciate all these questions. There we go. Let's share the screen again, and let me just get set up quickly. There we go. So we now created the new variable, but we want to have a look at what levels we are seeing here at the moment. So the levels, male and female. We're not seeing the missing. Well, I'm not seeing. Peter is seeing the missing. Interesting. If you do the levels, right, Peter, do you see the 3 levels?
In them now. I see, yeah, I see, but I see the codes, and then I see male and female. So the one that written nothing, but I see 3 codes.
Okay, yeah, okay. Okay, thanks so much. Let's continue. Righto. We see there, there's only 2 levels. We need 3 levels, right? So how are we going to do that? We're going to recreate the variable. We are going to use the add NA function, and we are calling up that variable we have already created, and that's totally fine. Let's see what happened now. Boom, we have 3 levels, female, male, and NA. But I don't like this. It doesn't look very fancy pants to me. I kind of want to change the label of that NA. So let's quickly see how we do that. We are going to do the following. We're going to say levels. We're going to say the variable. And then in square brackets, we're going to say the 3rd level. Use the assignment operator, because what we're going to do following is going to make more sense. We're going to use undetermined. So what we're saying is that I said relabel basically the 3rd level of the sex variable to undetermined. So let's do that. Boom. Let's go again and check the levels. Okay, cool. Male, female, undetermined. We can also be quite fancy and do the following. And it's not in the exercise, but I want to do this in any way. The 1st level is female, but I want to do this. The 2nd level, hi Tajudeen, welcome. There we go. I want to make the 2nd level to male. So we're just making the words a little bit fancier, right? And I'm going to execute those both together because I can. And I am going to call up the levels again and see what happened. Boom. And now it says female, male, undetermined. So let's run that plot again and see what is happening. So we remember, how did we do that? We said plot. We said surveys. We said the 6 variable, and yeah, I'm doing something clearly very wrong here. Why? Oh, sorry everyone, I'm upset now. I don't know why. I did change it. Who knows or thinks, oh no, you know what? Angelique, this is a rookie mistake. What am I doing? I'm telling it to plot me the original column before I even transformed everything. Hey, Angelique, sometimes, nah. Okay, so we created a new variable called 6, so that will now come up on your screen as the 2.0 plot, right? So there we go. We have a new label. We can even make that undetermined a capital U if that's what you really want to do by using the arguments we did above. Let's quickly go on. So the next one we're going to do, we are now going to format dates. Let's see what the time is. Okay, we still have a bit of time before the next break. Let's save our script again. I just want to close that surveys because we already used that. So in a common, we spoke about dates and the issues they might bring when we were doing spreadsheets on day one, right? So a common issue that new and experienced our users have in converting date and time information into a variable that you can actually analyze. Oh, sorry, there's something wrong through. Just give me a sec. So one way to store date information is to store each component of a date separately. We spoke about that, right? So we know this. You can run a structure analysis, but hey, let's have a look at the survey date again. If we look, there's a month column, a day column, and a year column. So we know that the dates, the month, the day, the year has been saved separately. That we know. You can also go and use the structure surveys argument if you want to see just what structure everything looks like. So now we are going to use the year, month, date, the YMD function from the package lubridate, which also belongs to tidyverse. But it gets installed as part of tidyverse, but we need to load it again. So let's quickly load lubridate. So we're going to go library, lubridate. You see it's picked up there. Let me run it. Okay, give me a thumbs up once you all have run the lubridate library package on your R. Awesomeness. Okay, I think everyone has, sorry everyone, I've been talking way more than I usually do this week, which is not an issue at all. So we loaded our lubridate package, and it has very useful function when it comes to working with dates. And these can help you extract data from different string representations, converting between time zones, calculate time differences, and you can find more information on this cheat sheet, which I'm going to copy for you now into the chat. So if you want to have some homework, that's totally fine. You can go and read that up. And for this next part, we're going to use the YMD, which is year, month, date function, which takes a vector representing year, month, and day and converts it to a date vector. So date is a class of data recognized by R, and being a date, and it can be manipulated as such, so you can do analyses with that. The argument that the function required is very flexible, but as a part of best practice, it's a character formulated as year, month, and date. So let's create a new variable first, and we're going to call it my_date. We're going to put an assignment operator. We're going to use the YMD function, and we are going to provide the date 2015-01-01, right? So the purpose of this, let's see what the structure of this new factor is going to look like. There we go. So it's in our environment at the moment. It says UTC, quite interesting. Let's call up the structure and see what happened. My_date. And let's see what happened. Interesting. So there's one date entry. Remember earlier when we did yesterday, it said numerical character when we set up those vectors, right? Okay. Right, sorry, I lost my train of thought here. So yesterday, is it yesterday? We created vectors. And when we looked at the structure of the vectors, it told us its numerical character, and it told us how many entries there were, etc. And this is exactly the same with this YMD, the year, month, date function we just looked at. So we're seeing it's a date. Boom, this is exactly what we wanted. There's one entry of 1. And the formatting is year, month, date. Boom, that sounds great, right? So now let's paste the year, month, and day separately, and we will get the same result. Have a look here. We're going to go my_date. We're going to put an assignment operator. We can use a YMD function. Now we're going to say paste. So we're adding a bit to this now. We're saying 2015, 1, the first. And now we are going to tell it, I want you to separate this by a hyphen. So let's run that and let's see what happened. It looks exactly the same. So those are two various ways, but to enter, if you want to make a date vector, right? A date vector. So I would prefer the first way because it kind of seems easier. However, you might want to do a bit more intricate type of things. So, and the second, it works basically, right? So now we apply this function to the survey data set. And we can create a vector from the year, month, and day columns of surveys using the paste function, right? I am going to quickly just get myself centered here for a moment. Righto. So we're going to start with the paste function. You can see it's part of the base R package again. We're going to use the surveys, and we are going to use the year column. We're again going to say now, I want to use the month column. And Angelique survey. We're going to say, I want to use the day column, correct? And I want us to separate that by a hyphen. Correct? Let's see what happens. Woo, a lot of things happened here. You see things have been changed and it looks interesting. If we scroll through here, a couple of lines of data has been changed. Let's pull up. Okay, so what they literally did is, it's only showing in our console at the moment, yes. So now we can use a character vector in this argument as well. So I'm gonna just copy this because I'm lazy. And now we're gonna paste that, but in the front, we are gonna put another square bracket, and we're going to use a YMD function, and we're just going to close it at the back. And let's see what happens. Ooh, 129 failed to pass. And we are expecting this. So there's a warning that tells us that some dates could not be passed by the YMD function. For these days, the function is returned NA, which means they are treated as missing values. We deal with them with this problem later, but first we add the resulting date vector to the survey data frame as a new column named date. So let's cheat a bit again, copy and paste. And now we're going to call it surveys, and we're creating a new column now called date. right? So let's have a look again how I did that. So we know all the other variables that are in, or not variable, well, columns, right? Variables in the surveys data set, but we want to create a new one. So that's why I use this. And okay, it again says fail to pass, but that's totally fine. Let's go to the data set that we kept open and we go way to the back. Boom, do you see there's a new column that was created? We can also use the str function if you want to use that. So now what I want to do is I want to check if everything worked great. So we're going to do the summary. You're going to check in on the new variable. Okay, so there's 121 NAs, meaning there was 121 entries that did not have dates. Fine, right? Because we know there is NA data. But now we kind of want to, how can I say, clear this missing data. And we're going to use the is.na function we spoke about yesterday. We call it missing dates. I already created this yesterday, so do not worry about that pop-up when I was preparing for this. So we're going to use the surveys data set. We're going to use square brackets with the is.na function. We're going to say, I want to extract or remove the missing data from the survey, the date column. And now we're getting all fancy. We're using the concatenate function again. We're saying year. Ooh, I need more coffee, clearly. And let's see what happens. Great stuff. And now we're going to go and use the head function to see what the missing dates look like. And there we go. Top 6, we are good. Awesomeness. Let's quickly recap what we did in this whole part, even some of yesterday. So the read.csv argument is to read tabular data in R. A data frame is the representation of data in the format of a table where the columns are vectors and all have the same length. dplyr provides many methods for inspecting and summarizing data and data frames. We use factors to represent categorical data in R. One of my favorite things to do in R is to play with categorical data. And the Lubridate package has many useful functions for working with dates. Now, let's check on the time quickly. We have about 10 minutes before we take a break, so let's get started with the next section. Righto, you can still see my screen, yes. So now we are going to start manipulating and analyzing and exporting data using tidyverse. Very exciting. Now we're going to start doing exciting things. Not that we weren't doing, just it's nice. Now we're going to use some data. We're going to see things. And this is going to lead us to data visualization. Okie dokie, let's start. The objectives of this section is to describe the purpose of the dplyr and tidyr packages. Don't worry, I'm going to explain everything to you. To select certain columns in a data frame with the dplyr function select, extract certain rows on a data frame, to link the output to another function using the pipe indicator, add new columns to a data frame that are functions of existing columns, mutate. We're going to use the split, apply, combine concept for data analysis. We're going to use summarize, group, and count to split a data frame. We're going to describe, this is getting long, we're doing a lot of things here, right? Describe the concept of a wide and a long table format, describe what key value pairs are, reshape data, and export a data frame into a CSV file, which is comma separated values, right? So data manipulation using dplyr and tidyr. So bracket subsetting is handy, and we're going to be exercising that the whole time. So it's a whole new concept we're learning now, but it can be cumbersome and difficult to read, especially for complicated operations. So now we're using dplyr, and dplyr is a package for helping with tabular data manipulation. It pairs nicely with tidyr, which enables you to swiftly convert between data formats for plotting and analysis. And I'm sure all of you are waiting for that plotting, right? The tidyverse package is an umbrella package that installs tidyr, dplyr, and several other useful packages. We're going to use ggplot2, tibble, and all these names are quite interesting. I sometimes wonder what went through the person's mind when they were thinking of these things, right? So the tidyverse package tries to address 3 common issues that arise when doing data analysis in R. The results from a base R function sometimes depend on the type of data. R expressions are used in a non-standard way, which can be confusing for new learners. And the existence of hidden arguments having default operations that new learners are not aware of. And all of us already installed tidyverse, so I'm not too worried about that. So what are dplyr and tidyr? The package dplyr provides helper tools for the most common data manipulation tasks. It is built to work directly with data frames, and many common tasks optimized by being written into a compiled language like C++. An additional feature is the ability to work directly with data stored in an external database. And we are now going to start using dplyr and tidyr, right? But before we do that, let's practice our live. It's already loaded, but let's do that. So we're going to say library. We're going to, let's say dplyr. Let's see if I run it, what happens. Oh no, if I run it, thank you. It's already there, but I just want to make sure everyone has it loaded, right? tidyr, and it's loaded. All right, give me a thumbs up once you have those 2 packages loaded. I'm going to share some extra reading material for you in the chat. If you feel you want to read more about dplyr and tidyr on the cheat sheets, righto. If you're done installing that, please let me know. Righto. It seems like we are good to go. Thanks, Yastil. Thanks, Bala. Thanks, Peter. Sorry, my voice is hopefully going to last for another hour or so. So let's say, so we have already run the data, but let's now, we made a couple of edits and things and stuff. So let's reload the data. Let's go surveys. We're going to call it surveys. Assignment operator. We're going to use the read.csv function, and we're going to call the data from where we have saved it. Data underscore raw. Sorry. Underscore data underscore joined.csv. Let's see. There we go. I've called it up. This I will quickly copy for you in the chat because this is so easy to get wrong. Remember, those of you who have saved your data in other spaces, to update the location. Give me a thumbs up if you are done with loading the data again. It's probably not needed, but I think let's just do it and make sure we all are using the same data sets. I'm seeing 1 thumbs up from Peter. Thank you. I'm seeing more thumbs up. Thank you, Eddie. Thank you, everyone. Okay, cool beans. So we have the data. We are good. Now we're going to inspect our data because I want to normalize this behavior in a sense when we work with data sets. STR, and we're going to use a surveys data set. We're going to say what's going on. Woo! Something big is going on here. And we know this from yesterday. We have 13 variables, meaning 13 columns, 34,786 observations, and we have integers. Let's just scroll down, characters, and we know it only gives you a certain little highlight of it, a preview of the data, right? Let's get a more in-depth preview of the data using the view. I already had it, there we go. We know what this looked like. We used it a couple of times today and yesterday, so we're good. I just kind of want to normalize again. We have a look. We know this is the data set we want to use, etc. So I am going to tell us now what we are going to do. In the next section, we're going to take a break. I just need to get something for my voice. Apologies. So next, we're going to learn most of dply's function. We're going to do select to subset columns. And I think, Peter, if it wasn't you, maybe you had a question about that earlier. Maybe the subsetting might help you too. Filtering, subset rows and on conditions. Mutate, create new columns by using information from other columns. That sounds interesting. It sounds like a lot of the stuff I did in my honors year. Group by and summarize to create summary statistics on group data. So we're starting to look at how we're analyzing data a little bit more here. We're going to look at arrange, we're going to sort results, and we're going to count. So we're going to start with selecting columns and filtering rows when we come back. Let's come back. We can take a 12-minute break. That's totally fine. We'll come back 10 a.m. Is that fine with you all? Go, get a cup of coffee, get a cup of tea, maybe a rusk or two, or whatever your preference is. Right, I'll see you all on the hour. Let me go sort out my throat.
coconnection free.
On the WhatsApp line 061 when we come back from the news at 10. So if you can't get through on the telephone line, send a here and something to voice note to the WhatsApp line 061 410 4107. Everyone, it's 10 o'clock. So let me start sharing my screen and we can get started with the next section we're going to be covering. It will be selecting columns and filtering rows. There we go. So to select a column of a data frame, we can use the select function. This first argument, or the first argument to keep this function in the data, blah, blah, blah. So what I'm trying to say is we're going to use the surveys data to test the select argument. So we're going to use select, we're going to use surveys, which we know we have. We're going to use the plot ID, plot underscore ID. We're going to use the species. Oh, am I spelling this wrong? I think I am. ID and wait. No, that's one we created yesterday. We're not going to do that. So we said, okay, in the select, in the surveys data frame, plot species, plot ID, species IDs, and weight. So let's see what happens here. Great stuff. So if you look at our, we didn't create a new variable or anything. So let's just see what is happening in our console. Boom, boom. It's a lot of data. There we go. So what we did is we selected plot ID, species, and weight. That's exactly what we wanted to do, right? What we can also do is you say select all the columns but some columns. We're going to say, again, the surveys data, that's what we're going to use. Which column should we not use? Record ID and species ID. And how do we integrate? Yesterday we did that minus sign. So minus record, minus species ID, and we're going to close that. And this is way too much to print, but I can promise you, if we have a look here, this is what happened. There we go. You see, month, day, year, plot ID, 6, hindfoot length, weight. So everything, and then genus, species, taxa, plot type. So we can see the select kind of helps us to build new data frames, right? So next up, you can also choose rows based on a specific criteria by using the filter variable, or the filter argument, sorry, filter. Angelique, you are spelling things wrong. So I'm going to say, again, use the surveys data set, year equal to 1995. So we are saying filter out the data where the year is 1995. And we can quickly, so it emitted 1,104 rows. And let's quickly go, I'm just screwed, there we go. If you look at the date, we can quickly see blah, 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 blah. You see 1995. And obviously you can save the select all these by adding a name and assignment operator in front of that argument. And then it is saved in your environment. So the next bit we are going to do is pipes. And it's not bagpipes, I can promise you that, or any pipe that you smoke. So no, it's my attempt on a very, very bad joke. What is, so what if you want to select and filter something at the same time? And there are 3 ways to do this. You can use intermediate steps, nested function, or pipes. And with intermediate steps, you can create a temporary data frame and use that as input to the next function. So let's see how we do that. We use surveys, but we're gonna create a new variable here now, right? So we're gonna call it surveys 2, so we don't override the one we already have. Assignment operator, we're gonna say filter. We're gonna say, what do we want to filter? We want to say surveys, all the weight column, everything in the weight column that is greater than 5, right? So we are creating a new, let's just run through this again. We are creating a new data frame called service 2, and we are filtering the surveys data frame that we have by weight, and only those whose weight score is smaller than 5, right? Great. So let's run that and see what happens. Okay. There's 17 observations of 13 variables. Now let's take it one step on. We're now going to create a new variable, surveys underscore small, assignment operator. Now we're going to use the select argument. We're now going to use the surveys to data frame that we just created. And we say only include species ID, sex, and weight. Ooh, something happened here. Can't subset columns that don't exist. A column doesn't exist. Ha! I have a spelling mistake, people. There we go. Great stuff. So now we're seeing what we did first is we said, okay, filter for me those whose weight score is 5, but also only select the species ID, sex, and weight columns. And if we look at this one now, this is the new data frame we created, right? Where 3 columns, where their weight is all smaller than 5. But there's another way to do this, and to do it a little bit quicker, but it's a little bit more complex. But we're basically going to put these little queries we created here, we're going to create them all in. So we're going to say surveys, small, we're going to override that, assignment operator, and here it gets fun. We're going to say select, and then we're going to say filter, and we are going to exactly do what we did above in this now. We're going to say user surveys, data frame we already created. We're going to say only for those whose weight is smaller than 5. And then we're going to go between the 2 curly brackets, put a comma, species ID, sex, and weight. We're going to run that. It says, whoo, I did something wrong again. There we go. And it says now 17 observations of 3 variables. This doesn't sound right to me. What did I do wrong here? We can have a look. Let's see quickly. I'm going to make that bigger. What do you think? For me, it should be exactly the same as that one, right? What did we do wrong? Let's double check, right? We called it survey small. We have an assignment operator. We said select, we said filter, we said surveys. We said weight must be smaller than 5. We said only choose species ID, sex, and weight. And yet, if we look at, oh, don't worry, Angelique. This is right. We have got the same output that we had previously. 3 columns. I saw 3 and I thought it was 13. So we have species ID, sex, and weight of the weight that is smaller than 5. So this is I want to say a one-stop shop query, but it can get a little difficult to read, correct? So we can use pipes to do this as well. So let's quickly have a look what pipes look like. A pipe looks like this. Let me quickly copy and paste for you. No, not that one, Angelique. Did I put my video on again? No, you'll think after 4 days of teaching this, I'll get the Windows thing again. Apparently not. So it is not a dollar sign, percentage greater than percentage, but there is a shortcut how to do this. So let me copy and paste this for you so you can see how we can make that. There we go. So you can do Shift M, Shift and M. No, why is it not doing that? Command Shift M if you have a Mac. Is it working for you? All Shift and M to get that $sign. Oh, Control Shift and M. Apologies. It's Control Shift and M. So let's try again. Boom, I got it done. Yay. Give me a thumbs up if you can do it on your computer. Okie dokie, I'm getting thumbs up. Great stuff. Obviously, you can $sign greater than, not $sign, percentage, etc. You can do that as well. It's not going to make a difference, right? So let's see how we can simplify the filter and select we did above using the pipe. So we're going to do the following. So we're going to call the data set up. We're going to Shift Control M, and then we're going to enter. And you see it kind of tabs in. We're going to say filter for me, weight that is smaller than 5. And we're going to use that pipe again. We're going to say select species ID. You see it's already popping up that other thing. 6. I actually want to go back and show you something here. So do you see there's 2 things that popped up there? Don't get confused because the purple one, oh, well, my screen's purple, right? It says that's the 6 variable we created. The top one, where there's an square bracket surveys, that's the variable in the surveys column. The column in the surveys data frame, apologies. And you can see it's a character and it's the data set is 34,786. So that's the variable we want to use, not the one we created. So that's just another way, if you name things the same, just to distinguish between that. So we're going to use that. And the last one we're going to use is weight. And I am going to run all of this. And what did we get here? It's the same, 17 entries with 3 columns. So this was a little bit more, it's easier to understand what we did here, right? If we now want to create a new object with the smaller version of the data, we can just assign a new name. So we here used survey small. I'm going to cheat and just put that in front of this in line 371. And it will now, let me just close this. We're going to survey small, and there we go. We recreated that. So there are various ways to use the filter and select. If you want to use them together, I would recommend you using the pipe because for me, it feels a little bit easier to do, and it makes a bit more sense. So next up, we're going to use the mutate argument. Let me just make space so that I can give us a heading here. Mutate. So frequently you want to add a new column based on the values in an existing column. So maybe you do a calculation, right? Like let's say BMI. BMI is body mass index. And if your data frame consists by height and weight, you can get a BMI score based on that. But you need to calculate that. But we can use mutate to do that. So let's quickly see. We're going to use the same weight analogy, but we are going to do some conversions to between kilograms and pounds here. So we're going to, again, pull up the surveys data frame. We are going to put the pipe in and we're going to enter. We're going to type in mutate. And we are saying, okay, I want the weight in kilograms. I think I have that variable in my environment. It might give an issue. Let's see quickly. Divided by 1000. No. Okay, so what we're doing, we're saying, okay, I want to do, it must, right? So we want to use the data we already have in our environment to create a new variable, right? That's what we are trying to do. So this is correct. We're saying surveys because we want to pull out the surveys data frame. We're using the pipe, which is Shift Control M or Command M in Mac. We are saying we're using the mutate argument. We are calling up the weight in kilogram variable, and we are saying it is equal to weight divided by 1000. So let's quickly see what happens here. Let's hope. There we go. Let's scroll up. Okay. So this is missing data. That's great. So remember it was in grams. So we converted it into kilogram now. Okay, cool. That looks good. You can also create a second new column based on the first new column within the same form. Interesting. Let's try and see that. So we did that already. Now we want to add a next step to that. So we're going to use comma and we're going to enter. No, we're not going to close that. Why? Because now we're telling it we ending our argument, which we're not, right? We're going to say weight and lbs equals the weight of the kilograms times 2.2. And this one we're going to close. So let's see what is going to happen here now. Great stuff. We're adding 2 columns now. So you can see there's NA because there's no data. It cannot transform anything. We go down. So this is 0.218 kilogram, which is 0.4796 pounds. Now, if this runs off your screen and you just want to see the first few rows, you can use a pipe to view the head of the data. So let's see how we can do that. So we are going to go back and we are going to call out the surveys data set. We're going to use the pipe function. We're going to use mutate. And again, we're going to create a new variable called weight underscore kilograms. And this is weight, the weight variable in the surveys data set, data frame. We're going to divide that by 1000. And outside the curly bracket, we are going to do the mutate again. And then we're going to say, give me the head argument, and let's see what happens here. Boom. So we said, just give me the top 6 here. Don't give me everything. But in this instance, it will only be missing values because there's no values. So we saw the first few records, right, are missing values. And if we want to remove this, we can insert a filter argument into the same query we just used. So I'm going to, just above mutate, I'm going to add the following in. Filter, not is NA because we don't want to see it. We're going to say we want the weight to be out. And we're going to put a pipe in again. So let us see what is happening here now. Boom, we're getting, it removed the missing values, basically. That's what we did. Okie doke. Right. Let's do a challenge. I'm going to put it in the chat for you. We can take 10 minutes for that. So the challenge says that create a new data frame from the service data that meets the following criteria. It contains only the species ID column and a new column called hind foot in centimeters, containing the hind foot length values, currently in millimeters, converted to centimeters. In this hind foot centimeter column, there are no NAs and all values are less than 3. Think about how the commands should be ordered to produce the data frame. Let's take, you know what, I'm going to give you 15 minutes because this might take a little while. So let's 10:35, we'll all convene, right? If you need any help, please let us know. I'm going to share the link of the information that we have just covered so that you can follow along what I already have done. There we go. That's the information. And get going. Enjoy it. It's a lot of fun, this part. There's about 5 minutes left. If you're done already, please just write done or give me a thumbs up. If you need more time, also reach out to me. We're doing okay for time today. Right, everyone, we have about 2 minutes left. Let me know if you need more time. Else we can go through it step by step in while I'm screen sharing as well. Right, that was 15 minutes. I'm not seeing anything in the chat about extensions. Let's have a look at the solution. going to quickly share my screen and let's go and have a look. So I'm going to read the instructions as once again. Create a new data frame from the survey's data that meets the following criteria. Contains only the species ID column and a new column called hindfoot centimeters containing the hindfoot length values, which is currently in millimeters, converted to centimeters. In this hindfoot centimeter column, there are also no NAs and all values are less than 3. So let's start by creating the name, right, that we would like it to be. So we're going to say surveys. I'm going to say underscore hindfoot centimeters. I'm going to say assignment operator, and I'm going to call up the surveys data set and use a pipe, right? Next, I'm going to use filter. I'm going to filter out the missing values. So we're going to say filter exclamation is dot NA. What variable we're going to use? We're going to say hindfoot length. There we go. And we're going to use the pipe to indicate again. Then we can use mutate. We are going to say hindfoot length. No, we're going to say hindfoot centimeters should be hindfoot length divided by 10. We're going to use that pipe function again. Then we're going to filter again. We're going to filter now all the hindfoot in centimeters that are smaller than 3. And we're going to use the pipe again. And finally, we're going to select only this columns we want to select, species ID and hindfoot in centimeter. Now, if we run this, let's see what happens. We called it surveys hindfoot centimeters. Let's make it a bit bigger here on my screen so we all can see. There we go. Right, who of you had got something like this? Maybe you can give me a thumbs up or yes. Was this a difficult one? I'm not hearing anything from you right now. So maybe you are okay. If you have any questions, this is the time now to ask. It was a bit challenging, Peter. Okay. But luckily we can go back to the video recordings and we can go to the curriculum when you need to apply this to your own data set. So I hope you can do that then. We're going to start with one bit before Tajuddin takes over. We are now going to look at the following. Let me just put it down for you here. No, not that, Angelique. Ooh, woo. You would think I know how to copy, no? We're going to look at split, apply, combine data analysis and the summarize function. But particularly right now, I see something in the chat. Let me just do that. Okay, thank you so much, Amy, for helping with that information. We're going to use the group by and summarize functions. We're going to have a look at that quickly. Right, so the group by is often used together with summarize, which collapses each group into a single row summary of that particular group. So the group by takes as argument the column names that contains the categorical variables. We spoke about levels earlier, so we're kind of going into that direction again, for which you want to calculate the summary statistics. So to compute the mean weight by sex. So let's have a look quickly there. So again, we're going to call up the surveys data, and we're going to use the pipe. Then we're going to use the group by. And the group by says you add the variable, do you want to group it by? And we're using the top one again because that's of the survey's data. And then we're going to use the pipe again, and we're going to say, please summarize it for me. Quite interesting that grammar of, so summarize in the States would be spelled with a Z, right? But here it's spelled with a S, just something that it just came to my mind. So we're going to use the mean. We're going to create a new variable that says mean weight. We're going to say, I want it to be the mean of the weight variable in the survey's data. There we go. Exclude RM, exclude there are missing values. And let's quickly run that and see what happens. Boom. So if you can see at the bottom, this is now summary statistics in a sense of things. Male, female. Oh no, this is the mean. I'm sorry. This is the means of everything. So the mean of the females with regards to the weight would be 42.2 and the males were 43 on the dot. So you might also have noticed that the output from these calls don't run off the screen anymore. You can kind of see it looks quite nice and tidy. It's one of the plus points when it comes to using these packages in R, right? So you can also group things by multiple columns. Let's have a look. So we just used like one thing here. Let's add to that now, right? So I am going to copy and paste this just to make life a tad easier for us, because we're going to start adding a lot of things. How are we going to adapt this? We're going to say not only by sex, don't group it by sex, we also want it by species ID. Right? We still want to keep the weight, we all still want to keep that, but now I want to add something extra in here. I want us to look at the tail end of the data. So let's run that and see what happens. Interesting. So now it's just giving us the male, right? They're giving us the averages. So we can kind of so this is the sex, the species ID, and the mean weight. And we can now start doing a bit of analyses on various columns or variables at the same time, which is very cool. But very interesting that Summarize has grouped the output by sex. You can override this by using groups argument as well. So if we want to do that, that would be also possible, right? So, Peter, go ahead.
I just want to know why did it give us this output of only males, and then also those only 6 observations, particularly why only males?
Well, you broke up a little bit for me here. Can you repeat that, please, Peter?
I just want to ask why it only gave us an output of only males for those species, because we have males and females. Why did they choose only males?
Because I use tail, right? And the tail will get up the bottom 6.
Males.
It grouped them by female and male. And because F is before M, remember I said R is very sensitive to alphabetical order, right? So let's say, no, but that's a valid question. Thank you. Let's say head. So now it's going to give us the top 6. So this should be now the missing values. Remember those NA ones. But if I take it out totally and I run this, it should give us all the data. Let's see. No, it's not going to, because it's just too much, I think. You see what's going on here. But so the NA, they will put the missing data first, and then it would be female, and then it would be male. So that's why, yeah. I think it's getting so much the data that, it gets difficult to see on a screen. And I think this is where this tool gets a little bit better in that thing. But thanks for the great question. Okay. It's almost time for Tajudeen to take over. So I'm wondering, should we take our break a couple of minutes earlier? We can have a 15-minute break before Taj comes and takes over for the rest of this lesson. I don't want to go too far ahead, and then he needs to run many things to get to where we are. So let's take a 15-minute coffee break. And when Taj comes, we're going to end this rest of this lesson. And I think it's going to go quite quick. So maybe you'll need some caffeine. Let's meet again on the hour, 11 o'clock South African time. Go ahead. We have a question?
Yeah, yeah. I think it's an oversight on my part. When you are visualizing the head and the tail, what does R assume, as in how you have ordered your data? For example, if you look at the data frame for surveys, if you order your data by record ID, this would be positioned in a certain way. If you order your data by year, everything will shift in a certain way. Maybe you start with the earliest year up to the latest. So when I say head, tail, so what assumption does R make when it's ordering this data? Is there some kind of a default to say the first column is the one that is ordered, and then it shows you the tail or the head?
Yeah, thank you. That's a great question. So I think it all depends on what analysis you are doing, right? If you're not doing any analyses and you're just saying, give me the data. So we take surveys, blank data, no analysis was done, no filtering, no mutating, nothing, right? It will literally give you the first 6 entries for heads and the bottom 6 entries for tails. That's the default. But because in this, the last example I gave, we were saying group them by sex. Because sex was first, that would be it would look at the male-female thing, right? So let's quickly have a look here. I want to show you something. Levels. Okay, I think let's just say surveys. Oh man. Okay, so we have to transform the data again, and we haven't done that. But we know the exercises we did earlier, right? When we said levels, it gave us female, because F is before M, and then the blank data. So it seems like R when we do heads and tails, and it depends how we group things and how we filter things. In this instance, it read it missing data, then female, then male. So it all depends basically on how we analyze the data. Does it make sense?
Yeah, okay, yeah, that makes sense. Then you order it yourself according to the...
Yeah. But if it's just the surveys data, it will literally, the data that you imported, the first 6 lines, that will be heads. The last 6 lines will be tails. So they're not going to discriminate against any variable. It will only be that. Amy?
Sorry, I just want to ask a kind of follow-up question to that. So if you just loaded the file and did nothing and then did heads, it would be the first 6 as it is saved in like the raw file, right?
Yeah. I think if we do it now, it should be that. Let's see quickly.
Yeah.
Because remember, R is great in that we are not changing the original data set. We are making new data frames the whole time. There we go. So that's the top 6. ID 172,224. Let's quickly see if I can. Oh, there we go. 172,224. 266. Yeah. It literally took that first 6. Okay, thank you for the great questions, everyone. Let's go on our break because it's now 10:02 anyway. And we'll convene at 11 and hand over to Taj. Thank you, Taj. We're taking a 10-minute break quickly. I will message you where we ended, okay?
Good morning. Hello, good morning.
Right, everyone, it's 11 o'clock. I'm going to hand it over to Tajuddin. I made you host, a co-host as well, so you should have the same privileges what I have. Taj, over to you.
Hello, good morning.
Hello.
Hello, good morning.
Morning, morning.
How are you doing? So let me continue if you are from where you stopped. All right. So the next step that we want to quickly do is to see how to filter out the missing values from the weights, then group them by sex and species, then try to summarize the weights, finding the mean of that weight. So the last step you did was this, and I hope all of us have been able to do it before now. So let us continue. The next step was, is to try to filter out the want to filter out, you use the colon, then you want to filter out those missing values from weight. Okay. Then you put it in pipeline. I hope you know the shortcut for pipeline. You press down your control key and the shift key with M. For those of us using the Windows environment, so then you group by sex and species ID. Okay. After grouping those things, you also put them in pipes. Then you try to summarize what we have. Summarize. Okay. Just summarize. What this summary, you want to put it in new column. Put it as mean weight. Then you assign the mean value. the mean of weights. That's what we want. So you can run this path. When you look at the output here, so let me go down and show us the output. So this is the output. We have the sex grouped by the female, male version. Then we have the species ID, the last part. Then this is the mean weight. So quickly do that so that we can, if you run it, let me know that it works for you. Try to compare the values that we have with what you have on your own. Okay. So the next thing we want to also do is to see how to print the first 15 values, the first 15 lines of the output we have here. I can copy it and add a line towards it. First, I need to copy this out. Then put it in pipeline as well. Then print out the first 15 lines. You use the print statement to filter this out. Then we can run the output. So let me see.
I'm sorry, do you have a question?
Yeah?
I have a different output to you.
I didn't get what you are saying.
I have a different output from what you got when you did the first summary for main weight.
Okay, what output do you have there?
There by group, I have, there you have, it says 6 by 3.
Can you show me your screen, please? I will stop sharing my own screen. Show it so that we can get it. Can you show your screen? I've stopped my own screen. Let me see what you have there.
I have this one. You can see.
I'm trying to figure out what happened with the output there. Probably you would have done some few things before I do it here. Can you scroll up from this other side? Okay, scroll it up.
Yeah.
I want to see the last step you run. So what do you need to do for me? I know, no. I want to know what you run last before the species changes. What happened is this: you have it for the tail here, so the value is still for the tail. I mean, it is from the tail you have. So this will be in memory. It will be the one in memory for now. So when you run it again, so it will display another value entirely. Let me go back and run my own.
Okay.
Stop hearing. Hello, Peter.
Yes.
Okay,
Stop sharing.
Hello, I can't hear you clearly.
I can hear you. I stopped sharing now.
Okay. Thank you. So let me go back and get my home. I want to see what happened there. Okay. I'm coming. I want to rerun my hand, the one at my hand.
We're not seeing your screen yet, Tajuddin.
Oh, okay, sorry. I want to share the screen back.
Super, we see it now.
Okay, can you run this part? I want to see, because I know there is something wrong with it now. It's still loading this. Run this part. I think that is the one, the value that is still in memory. Can you run this aspect part? This is
Yes, I did, yeah.
so it's the one still in memory. I believe that is still in the memory.
Yes.
Okay.
Yeah, I ran that one of the tail and then I got
Okay, it's still in the memory. That's the one in memory. So let me try to run this now and see the difference between the two. But I don't know why it's still giving the same thing. Don't know why it's still giving the same value. Let me try to figure it out. I want to try to figure out what is happening there. So let me first change this part. I want to change this to run without the tail and see the output. Here is the output. Let me move it up. So if I run it with the tail now, it will give me the first 6 values. So this is what I am expected to have. So if let me do it with the head, trying to have the head from top and see why it is not running. Something is wrong. I don't know. I can try to figure it out now. Okay, this is ordinary running with let me change this. Well, I don't want to try to compare my own memory. Is something is happening in the memory. It has a value in the memory for now, which I cannot try to figure out. So I think we can just proceed. We can just follow the basic coding that we have. So the next thing that I said we want to do is to, after trying to summarize what we have, we want to find the first 15 lines of the output. My home may not work for now, I don't know. So just add, you put everything into pipe and try to print out using the print statement for the first 15 lines. Can I kindly do that so that we can proceed? Try to run that as well. My home may not figure out. You can see something is still happening. Let me go and view what I have there first. I will try to view the output on my own hand so that I can figure out what is happening. Something is obvious here, and it's printing the value. Can you do the view of surveys? Let me see. Are you having 17 rows? Try to confirm. Are you having 17 rows in your own?
Should surveys not be that 34,000 entry? I remember in the previous steps we
it means
we
that
mean-
I have been something.
Right.
Let me go back and
yeah, maybe just load the
run my
data.
own. I want to rerun my survey. I want to rerun the survey.
Yeah, line 5.
I will continue from there. So let me
Yeah,
view
then
it
I think
now.
everyone will be on the same page.
I can view it now. Let me try to view it from here. Okay. So
There
the
we
last
go.
value should be. So I think that is the major problem. So this is the. So I have everything now. So let me go back and try to run from here, from this end. Okay. So you can see that it's changed it now. Okay. Now let us try to do it now. Okay, it has changed now. Hello, can you confirm now? I've been able to change it. It is now 64 rows by 3 columns.
Looks the same, Peter.
Yeah, now same as mine. Yeah, same as mine now.
Okay.
Oh, great stuff.
Okay, all right. So let us now run this aspect. Whenever you have a problem, issues, try to go back, try to find out, try to view first, and you'll be able to know that there's a problem somewhere, so that you can try to correct it. You see the way I've tried to view it. The first one is to go back and load my survey. I try to read back my survey, then try to view it to know what is happening. Then I was able to figure out that something is missing from just a few lines before what I run. Okay, let us proceed. So the next thing that we need to do, we have been able to figure out the first 15 values. Now we want to find we have done the mean. Let us try to find the median value, the minimum value there. So what you need to do at this part is to copy, just copy this first part, the survey here, copy it out, then paste it in another value, then try to include the mean weight. Let us put the mean weight. Then what is the mean weight? You find the mean of weight. So you are going to have another column that is inserted into the code. Then when you run, you can see the value now. Oh, there's something wrong there. Okay, something. I have 3 open cells there. Yeah, let me quickly correct that. It's supposed to be 2. This one we close. Oh, okay, I missed out. I missed out this. I need to close this before opening the other one. So let us run it now. Okay, it has gone. So let us see the value. You must have 64 by 4, 64 rows by 4 columns now. Run it and try to correct and see what is happening there. So we have it says the species ID and the mean weight and the minimum weight there. The mean and the minimum. There is difference between finding a mean value. The mean value will sum up everything and divided by the number of values there, while the mean will find the minimum value there. You can also try to toggle out by trying to look at, let me look at maximum weight so that you can see the difference on this what we are trying to put across. Maximum weight. So I just want us to compare what we have there so that you know the difference between the minimum and the maximum. So when you run the value, so we have created another column so that you can see that at this end, the minimum weight is 24 and the maximum weight there is 50, while the mean weight for that cell is 38.3. So I just want us to know the difference between the mean and the minimum value so that you can see the difference there. Are we, ready to go forward? Try to indicate number so that we can proceed. So the next thing we want to do, the next thing is to find the average of the mean. So what I need to do here, I can still include that of the weight. I just need to copy this out, straight out, copy it to another variable because of you don't want to be moving around. So you put everything into pipeline, into pipes. So one good thing about pipe is that let's say I want to run this aspect, this part, I can view it. Okay, I can view that aspect. Let me just run it so that you see. It will filter everything out. Then if I now decided to say, okay, let me group and do the grouping from this one to the group. To the group, sorry. To the group, yeah. If I run this one, it will, sorry, it says I need to add everything with this to the group. It will just run the aspect from the group. Then if I want to proceed to go further, I can get this out to the next line. So now we want to put everything into pipeline and find the average. Find the want to arrange, sorry, we want to arrange the cell. Want to arrange by mean weight, by the mean weight, just by the mean weight. The mean weight, that's what we want to use to arrange the cell. So, sorry, let me error. You must be very careful while typing. So I can now run everything together. So it has been able to arrange it. The minimum, the lowest value there is 4, followed by 5, then followed by 6. So we arrange based on the minimum weight there. Okay. So if you have done that, let me know. So another thing that you can do is to describe the mean weight. You can describe the mean weight. How do you do that? Using the arrange value. So what we need to do, I can copy this cell. Place it here. Then change this using the description. What the description will do is to find the mean, median, the maximum value, the minimum value. It will describe just the summary of what you have in the set. It will only do it for the values that has integers, not those character sets. I hope that is clear. So I need to change this to mean, because we want to describe this mean weight, but it must close it out. So it has been closed completely now. So when you run it, you can see the description. And been able to describe it out. This is the description. First, you describe it by cell. It is for the male cell, for the female, using the species NL. It will summarize NL each of the cells. NL, what is the mean value there? It tells us what is the maximum minimum value. It will describe it. What is the maximum value? It will describe it. So that's how to do it. Kindly do your own and let me know if there's any error before we proceed. If you have any error, let me know. Okay. So the next thing that we want to see is to count. You want to use count the values using the count function to find any of the cells that we want. So let me try to say that we want to use a particular column. Can you observe one thing there? When I was trying to type out the name of the column, it displays the variable because this is what we have. So if I decide to say I want to print it out, it will give me the value. So any one of them that you select here, it will display it for you to view it, but not in memory. You can see the display. Those ones that I can see out. So what I wanted, so this is not where I want to type it. I'm sorry. I want to type it at this very moment. Okay. So you put it in pipe and you want to use the count function to count the number of male and female in the column sex. So let us run this out. So we have been able to see that the total number that these are missing values. Those ones that don't have any value assigned to them, they are the missing value. And the number of female there is 15,690. The number of male is 17,348. So I will want us to try to count the species ID. Use count to find the species ID. Okay, so let us quickly do that before I do my own. You can share your screen with me if you have been able to use count to find the species ID. I mean the count of species ID, those values you have there. So let us quickly do that. So you change what? You change the variable from sex to species ID. So what do you have? Let me run my own. So I've been able to run species ID. The species ID with AB, we have 303. With AH, we have 437. So if you have similar thing, let me know. Thumbs up so that we can proceed to the next thing I want to do. We can quickly see how to use the count using the group by and try to summarize the count, the number of n there. Let us see how to do that. Put also the cells. Let us put it in pipe. Use the group by function. What do you want to group by? You want to group by cells. You group by cells. Put everything in pipe. Then try to summarize. Using the count to equals to the number of missing value. And let us try to run it and see what we have there. What will be the output? So you can see, so it is similar to just using the count here. You can see, still the same thing. So this one is simple than using this other long method of trying to group by first before trying to summarize. So if I run this again, you can compare, you can see the value. And when I run this, it says the same value, but there is still the same value. So you must try to be able to know what to do, find a short way of trying to find the number of count variables. So we will go for a break in the next 2 minutes. We have 5 minutes break so that we can proceed for the other things that we want to do. So now we want to sort the cell with the count of the cell. We want to sort based on sorting. So what I need to do is to just add sort to this aspect. You have the sort function, and it must be true. It must be true. Yeah. So let us run it. So you can see that it's sorted that with based on. You can sort. This one is sorting based on descending order. It is based on descending order now. It's sorted with the highest value to the lowest value. So it's sorted with what? Descending order. You can change the sort mode if you don't want it to be in descending order. If you want it to be in ascending order, you will specify that it is first, so that it doesn't sort it with the ascending order. So we will go for break now. Then we'll come back in the next 5 minutes. We'll come back by 11:40. So let us take a break. I will stop sharing now.
Sorry.
Hello, yeah, yes.
Hello?
Hello, I'm listening to
Yeah,
you.
so if I probably didn't get it. If you want to sort in ascending order, I don't think I got the code. Because this one is sorting in descending order. Yeah.
Yes, if you want to sort with the default is descending order. You can see, you can check,
Yes.
you can try to check out. Let me just share my screen so that you see how to look for app on sort. So what you need to do, let me share the screen. So that you see what I'm trying to do. So I go to the console. I don't want to put it here. You put app, then sort function. You can see the sort function, run it. It will tell you how to decrease. So decreasing first. If you want to put it in decreasing order, you know I said the default is decreasing order. So if you want to put it, you don't want to put it in decreasing order, you change it to true or false. Okay, so let us go back here. Want to put it in descending order, so I can change this out. I can try to sort it and put it in descending order. So descending and decreasing. Sorry, I need to put into sort. So you can say you want the cells and change to decreasing. You set the decreasing to false. So let us try to do it and see if it's wrong. You can see it's showing the value, but this one group everything. I don't want it to do that. So let me see. If this will work for me. Sorry. Okay. You can see. Hello, Peter.
Yes.
Okay. Can you see what I've done?
Yes.
Okay. So if you want it to be in ascending order, I mean descending order, you can change this to true now. Put it to true and run it. You can see it changes, okay, from ascending order to what? Descending order. So we just need to change the decreasing to either true or false. So if you don't get it, you try to look for F using the sort. You can type your F, the sort function, and you run it out to look at it. If you don't want to do that, you can try to see if you have the sort at this other hand. You can see this environment, the pane environment here. You can just type it there and look for sort. If we give you the sort in order, so you can go through it at your own time. So let us have a break now. Then we'll come back in the next 5 minutes. Sorry, because we have run out. Hello?
We can hear you clearly.
Hello, yeah. Hope you are ready to go. I hope we have everybody back. Okay, let us continue. So from where we stopped, I want to proceed further. So we have been able to see how to do our sorting. So want to see how to count the number of cells and species. We want to run this out. Just add your count. You want to count cells and species alone now. You can count any other one. You can count your species ID if you so like. You can count the number of species you have there. So let us see the number of species. So you have this value. I can print the first few values there. Let me put this in. Sorry. Undo. Let me try to print out the first few values so that you'll be able to see it is more. Let us see the first 15 values there. Oh, sorry. I use it is case sensitive. You must know that your arrow is also case sensitive. Why is it not working? No print specification. So it's not working. So I want to print out the first few values, and it's not working for me. So the next thing is to try to group this and arrange them into species in ascending order and describe the species that we have. I want to find the species that we have. Then try to describe what we have there using n as your default value. When you run it out, you have the description. I will explain the difference between the first part, this part, the output without describing it. This output here is different from the other output. What this output is doing is to the missing values based on species and also group them based on the cells. Based on the cells. So let us see the output. For the first value here, the species albicula, the number of females there was counted to be 675, while the number of male happens to be 502. The missing values there, they are 75 for albicula. Then for bony, you don't have the female, you don't have the male. So the missing value is just what was counted out. The lady also was counted and grouped them. So if we group by the missing value, the male and the female. So that is what we are trying to look at here. where you use the arrange and specify. So we want to quickly look at the first challenge. So the first challenge that you need to do, you want to count how many animals were caught in each plot type surveyed, in each of the plot type that was surveyed. That is, you need to use the plot ID to look at that, count the number of animals that was surveyed. It means you must change this to be arranged so that you can specify by each of them. So let us quickly do the task, then we go through it together. I give you 2 minutes to try to look at the task, then we will try to look at it together. Just count by plot type. Have you been able to get it out? You see the plot type. This plot type here, that's what we want to count. So the column is plot type. We want to count it out.
Oh, should we have a suggestion in the chat?
Okay, let me see the suggestion. Let me see. No, we want to just do the only the plot plot type, not plot ID. Sorry, plot type. It will work for this one if you are trying to run for the plot ID to count against the species. It will work. So if you copy that out and run it, let me try to run my own. And you run it out, you can see the output. So if you run based on your plot ID, it will give your plot ID and species. Then it will arrange counting by the species name. But this is not a good way of trying to look at it because it will not be able to group it. It will group it based on the number of species plot ID. It can count and it will be very long. So you can see that you have a lot of species ID there. So they are not like when you have just 3 variables or 4 variables. Okay. So the variable, the number of ID there, they are more. So you don't need to do that. So what we want is just the count. We want to count the plot type. The plot type, not the plot ID. And you run the, and let us see. So you can see the plot type. We've been able to count it. For control, the number is 15,611. For the long-term crack exposure, you have 5,118. Rodent exposure, short-term crack exposure, and spectab. So you can see the counting there. So that's the first task. So we look at the second task. Okay. So let me copy the second task so that you can see it. The second task, I will break it so that we can read. Don't worry. So the second task, you will want to try to find the mean, the minimum value, and the maximum value of mean foot length for each species ID, using the species ID. Then also, and also add the number of observations. That is when you use Rn to find the number of observations. You can use the describe to do that. Quickly, let us see how to do that. Then we will come back to look at it together. We are using the group by. Know that we are using the group by and the summarize function to do it. You may not get it at first, but know how to use a group by. First is for you to filter out. Just first filter out, because you don't need everything. You need just the int foot length, the int foot length. Filter out those ones that are not the int foot length. I'll just give you us 3 minutes to do that quickly. Let me stop sharing while you do your own. No, I understand. So let us see the solution together. Let us try to look at the solution together. Be able to figure it out together. Let me look at the chart first. I think that somebody is going to send the chart. Let me view the chart. Okay, so let us proceed. So the first, we need to put the survey, use a pipeline. First, let us filter out those ones that we don't need. We don't want those missing values. We don't want the missing int length foot. Okay. So first, if we run this, let us see the output. So this is the output. So let us now use the group by. We want to group by. Group by. So what are those things that we want from the group by? We want just the species ID. You group by the species ID. So you can input the species ID there. Okay. So let us see the outputs before we proceed. So we have been able to group by the species ID. So can you see it? This is the group by the species ID. Okay. So the next thing, we want to summarize based on the mean value, the minimum value, and the maximum value. You also use a pipeline to anchor everything together, put them into summary. You want to summarize. First, we want the mean, so you can change the value, because you can name your cell to be the mean of the int. You have the mean for the int foot length, the int foot length. You can just give a small name so that it will not be too much. So what do you do with it? You find the mean of what? Int foot length. Int foot length. Okay. So if you run everything with this, let us see what will happen. Sorry, I want to. So let us run. So this is the output. So let us also add the mean value. Sorry, I want to break it, but it's not breaking. So I don't know what is happening. Something is happening with my. Let me copy it back. Okay. So we have the mean for the input. The input length, you name it as mean of the input length. Okay, so let us close this and run it out. So equals to. Okay, we have added the mean foot length. So let us also add the maximum of the input length. Maximum of the input length, you use the maximum value, input length. Okay, so let us run this also. This is the output. We started grouping it first by species ID. Then we try to find the mean of each of the species. Then we proceeded to the minimum value and the maximum value. So can you run your own and let us see if it is the same thing you turn out? so that we can move to the next challenge. I want to look at the next challenge. Hello? Can you hear me?
Yes, we can.
Okay. So the next challenge is this. I've placed it here. The next challenge. Sorry, let me view so that you can view it properly. You want to look at what is the heaviest animal measure in each year. Then group return the columns here, the genus, the species ID, and the weight. So you need to use your filter by year, then try to select from it your year, genus, species ID, and the weight column. So those are the things that you need to do. Or you can first select, then you filter by year. So let us quickly do that. I will stop sharing. So let us quickly do this challenge. Because of time, let us go through it together and see what we are expected to do. So I'm sharing my screen again. So we run through this together. Survey. Let us put it in pipeline and try to filter out first. Filter out those missing value. We don't want them. So you just need to, I don't want the missing value. It's not there in here. I want it out. Okay. From weight. So that's what we want first. From weight. So let us run it. So this is what we have, the output looks like. So we filter out those values that we don't want from weight. Then the next thing, sorry, this is the output. The next thing is to group by year. So let us group. First, you need to put pipeline. You put it into pipe. The output you put there, you group by. Yeah. Okay. So let us see the output. So this is the output. So the next thing is for us to filter out, look for the maximum value. You put everything in the pipe and you filter out based on the maximum value. I want the maximum value from the weight. I want the maximum. Set it equals to the maximum of weight. So let us run everything. So there's error. So let me just look at the error. We get a name input. So let me check the name. There's a problem with the name input. Okay. I'll just change it. There's an error. So let me try to figure out what is the error here. Okay. So there's a name input. So I don't want to use that. Let me change the name. I want to filter out. Filter out. Okay. I understand what is happening. You must use a double equal sign for this out, because it's not an assignment variable. Look for the word name. So let us run. This we want to filter out based on the one that is the maximum value. So when you run it, the output is there. And see the output. This is the output based on the maximum values. Then we want to group, want to select just the few ones. What do you want to select? You want to select here. You want to select those ones in here. Genus. You want to select special ID and weight. Those are the ones that we want to select out. Okay. So let us run everything now. Okay. So we have been able to run it. So this is the final solution. We have it based on year, based on genus, based on the special ID, and based on the maximum weight of the the maximum weight. So can you run your own and let us see if you have any problem? Let me know. So finally, we want to arrange, we want to sort it out. Let us try to sort out. Arrange by year. Okay. Let me put it in pipe. All right. So here we go. We started with 1977 and it goes down to 1985. So quickly do that your own. You have seen the way to use your pipes to put things together now. So whatever you run, you can hold on to it. Then try to run it using pipe to further filter it out or select some cells from it. So that means the message, I don't know what, okay. We are almost done with today's session. All right. We are almost done. So we will quickly check some aspects we want to look at now. I will show us this screen to describe a particular aspect we must know while trying to reshape our table. So I will share this screen. I will stop this and share what that means to us. Okay. So I want to share this aspect so that we understand this and what our table normally looks like. Okay. So can you see my screen?
Yeah, we have a hand from Peter.
Hi Taj. Now I see we sorted the heaviest species and they came with from I think 1 to 17 or more. So now how if you want to fit out the heaviest one among all the species, what argument will we put there?
So can you repeat what you said? I cannot get it out. Hello, Peter?
Yes, I was saying now we filtered the heaviest species per year, right? And if you want to
Okay, by year, okay.
Yeah, but if you want to filter out the heaviest species across the whole species here, but you want to select the heaviest one, how would you put that argument?
Okay, we want to select by everyone, not just by the year, or that's what you mean?
But I don't select the heaviest species among across the whole data. Which species was the heaviest?
Okay, which species was the biggest of what you said, Abby?
Which one was the heaviest? The one that weighed more than all the species, the heaviest species.
Okay, let me, because I don't, let me go back to my, and share the screen so that we can go through it together. Because I did not get what you are trying to put across. I will run this, I will show you my screen. Okay. Can you see my screen now? Can you see it?
Yes.
Yes.
Okay. So what you are trying to say that if you don't want to group by year, is that what you are saying?
Yeah, I want to like filter out to see which species is the heaviest one.
The heaviest one or the biggest one, or what do you think? Can you type it into the chat? Because I cannot get the. Okay. All right. How do you know now filter out the heaviest species across the data set? The heaviest. Okay, based on weight, you have to look for based on the weight, heaviest species there. Okay, let me see which one will give us the heaviest species based on what we have here. Okay, the heaviest should be the maximum, the one with the maximum value, the one with the maximum value of weight, which should be, when we arrange this, when we try to sort it out, when we try to sort the weight. So let me see the sorting. Let me put sort here. It will come with ascending order. Let me run next now and see what that will be. Oh, it's not sorting. So I can still do some few things. This one is not sorting here. What I will do, I can put it in the arrange value so that it can come with the sorting. I can just put it there or put it there with the select. I can sort here. I can sort it here. Let me run it. If it works, I think that will be. Oh, it's not working here. The sort is not working with this. I will figure it out. Minus 0. Decreasing. I'm not sure if it works, but let me just try it first. Oh, okay. It's not working. I tried to sort it out. It's not working. I tried to sort it. Can see the output. It's not working. Or let me say arrange by weight and year. Or arrange by year and weight. Sorry. Let's see if we can arrange it by weight. Maybe that will work out. It doesn't work. It's not working. It doesn't work with weight. I tried to sort it. Arrange it by weight. It's not working.
I think it was working, but it was descending, or rather, it was increasing.
Yeah. Okay. Yes. But no, it is not increasing. You can see that this is 274, and it goes down to 243. So it's not.
I think mine worked.
Your own work.
Yeah, for some reason.
Okay. Can you share your screen? Can you share the screen? Let me do both year and weight.
Can you see the correct screen? I've got too many things open.
Okay, let me stop my own screen first. Okay, can you share your own?
Are you seeing my screen? I don't have the correct one.
I've seen it. Okay, let me see the output.
So this is the one?
Yes.
Sorry.
I've seen it. Look at the output.
I don't know if this is increasing. To me, it looks like it's increasing. Like it's going downwards.
Yes. No, it's decreasing. That is decreasing.
Yeah.
It's decreasing.
So if it can be done the other way around.
Okay, can you put here along with the width? Put here inside it.
In front of weight?
Yes, and the weight.
After weight.
Okay, after I'll run it, let us see. Just click on that, no problem. No, there's no point. Okay, let us see the It will not sort, it doesn't sort with it.
No, it's only sorted
Okay.
by you.
It's just by the arrangement, it's not working with both of them. So you just pick one of them to sort it, except we put it I can put in cell so that it can work with both of them. So at least we know what we have to do now, how to arrange. We can read further with the arrangement for multiple cells. I hope you get that out. Hello, Peter?
Yes.
I said we can read further on how to do the arrangement for multiple cells.
Okay.
All right?
All right.
Okay. So you can stop sharing your screen. So let us quickly look at the pivot longer and pivot wide that I wanted to show to us before we call it a day. When are we rounding up? So that let me walk towards it. I said I want to share with us how the pivots were. We want to share the screen with us. Sorry. Have I pressed the sharing? Okay, let us see. Sorry. This is not what I want to share. I'm sorry. Let me stop. Sorry for the mess up. Okay. Okay, let me share the screen. Can you see the screen now? Hello? Can you
Yes.
see my screen?
Yes, okay.
Okay, so I want to explain the pivot longer and the pivot wider for us to understand. For the pivot longer, it will use them like this one. You can see the way it's describing the ID. Look at the ID. If you pick it one after the other, and the line will be very long. But for the pivot wider, rather than using it as a long column down, it will bring it as a column and rows. Though the other one is also column and rows, but all the keys, all the ID will be on one single column down. All the keys also will be on one single column down, and all the values also will be on one single column down. But for the pivot wider, it will change it to, it will group them by ID. Then on each of the ID, it will sort by the keys and the values. So that's the difference between them, because it will sort by the key, this key, the key, and the key. So we want to look at how to use it in our own understanding, where you are using the pivot wider. Use it to transform your survey to find the mean weight of each genus in plot over the entire sample. So you can just, for the test, see how to use the pivot wider. I want to group it. I will stop sharing so that you can do it on your screen. So you use the group method. Okay. So let us start. So what we want to do is to run this using the pivot wider method. The pivot wider use the group by. So we want to group based on the genus and the plot ID. So when you run the output, I didn't pick up. You can overwrite using the, let me first run this. I want to run it cell by cell. First run this out. Try to 32. Okay. Then put everything undo. Goodbye. Let me go by that. And let me try to filter out everything. Dot groups argument. Okay. There's something that says we can do. So the summarized version is this and this. I don't know why it's doing that. You can override using the dot groups. Okay, let me see how to override it. Dot groups. Okay. Dot groups because okay, let me see. Dot groups. Would that work? Wait is not fun. But well, wait. So something is not working. To him the column and find the name. My internet is not stable. Element has been grouped out as grouped out on pages. Okay, do that. Groups. Still not working. I think we can look at it tomorrow. Is Angela there? Hello?
Yep, I'm here.
I think this should be the last aspect. Or when do you think we can stop?
We can stop when you write. That's fine.
Okay, okay. Let me stop here so that I attend to questions. My house is not that clear again. So you can ask your questions so that we look at things together before we round up. I will just attend to questions in the next 5 minutes. So questions? Any questions? Hello? I'll stop sharing. Stop sharing my screen. I will attend to questions. Questions or comments so that we can round up for today and prepare for tomorrow.
Thank you so much, Gia. Gia is going to take over tomorrow. I'll be supporting her. So
All right.
excited about that. Yeah.
Okay. All right. Thank you.
Thank you, everyone.
Thank you. Cheers, everybody.
Bye.
Okay, bye.